For decades, we've been told a simple story about Easter Island. Remote, isolated, a Polynesian population that destroyed itself through ecological collapse. But what if almost everything you thought you knew about the people of Rapa Nui was incomplete? New genetic evidence has just rewritten the history of Easter Island, and the implications are staggering. This isn't just about one island. This is about transoceanic contact that occurred 300 years before Columbus. This is about voyages that shouldn't have been possible. And this is about how modern genetics is forcing us to confront uncomfortable truths about prehistoric contact between two worlds. I'm going to show you evidence that the people of Easter Island carry DNA that tells a story no history book prepared us for. A story of contact, of incredible voyages across the largest ocean on Earth, and of genetic mysteries that scientists have been arguing about for over 70 years. The truth about Easter Island is far stranger than the myth. Easter Island sits in one of the most isolated locations on Earth, over 2,000 miles from the nearest continental shore. When you stand on Rapa Nui and look east towards South America, there's nothing but open Pacific Ocean for thousands of miles. The traditional narrative is straightforward. Polynesian voyagers discovered and settled this remote island around 1200 AD, bringing with them their language, their culture, and their Polynesian DNA. End of story. But there was always something that didn't quite fit. The sweet potato. This humble crop, which the Polynesians called kumala, originated in South America. Yet somehow, it spread throughout Polynesia, reaching islands across the Pacific long before any documented European contact. The Polynesian word kumala bears a striking resemblance to words used for sweet potato in northern South America, where the Kanyari people called it kumal. How did a South American crop reach Polynesia? And more importantly, how did the linguistic connection happen? Thor Heyerdahl, the Norwegian explorer, famously argued in the 1950s that South Americans had sailed to Polynesia and even played a role in settling Easter Island. He built the Kon-Tiki raft and sailed from Peru to Polynesia to prove it was possible. The academic community largely dismissed his theories, but Heyerdahl was asking the right question. Was there contact between prehistoric Polynesian and Native American populations? For 70 years, this question has been one of the most controversial in Pacific archaeology. Small genetic studies produced conflicting results. Some found Native American DNA in modern Easter Islanders. Others found none in ancient remains. The debate raged on. Until now. In 2020, an international team of geneticists published a groundbreaking study in the journal Nature. They analyzed the genomes of 807 individuals from 17 Pacific Island populations and 15 Pacific Coast Native American groups. This wasn't a small sample. This was the most comprehensive genetic analysis of Polynesian populations ever conducted. What they found was extraordinary. Using advanced genetic techniques, the researchers identified clear evidence of Native American DNA in eastern Polynesian populations, not just on Easter Island, but across multiple island groups in remote eastern Polynesia. Here's what makes this evidence conclusive. The researchers used multiple independent methods that all pointed to the same conclusion. They used admixture analysis to identify ancestry components. They used local ancestry inference to trace which specific segments of DNA came from which populations. They analyzed identical by descent segments that reveal shared ancestry. Every method confirmed the same finding. Native American DNA exists in eastern Polynesia, and it's not modern contamination. The genetic segments carrying Native American ancestry are short and fragmented, exactly what you'd expect from ancient admixture. When two populations mix, Their DNA initially comes in long chromosomal segments, but with each generation, recombination breaks these segments into smaller pieces. By measuring the length distribution of these segments, geneticists can estimate when the mixing occurred. The answer? Around 1200 AD. Roughly 800 years ago. Centuries before any European arrived in the Pacific. This is prehistoric contact between Polynesians and Native Americans, and the genetic evidence is unambiguous. But here's where the story gets even more interesting. The DNA doesn't match Peru. Thor Heyerdahl sailed from Peru, and for decades, researchers assumed that if there was Native American contact with Polynesia, it would have originated from Peru. After all, Peru is the closest part of South America to Polynesia. The genetics told a different story. When researchers analyzed which Native American population most closely matched the DNA found in Polynesians, they found something unexpected. The Native American ancestry in eastern Polynesians clusters most closely with indigenous populations from Colombia and Ecuador, not Peru. Specifically, the genetic signature matches the Xenu people and other indigenous groups from Colombia. This makes sense when you understand Pacific currents and winds. The Pacific coast of Peru is largely desert, unsuitable for building the large sailing vessels needed for transoceanic voyages. But in Ecuador and Colombia, the coast transitions to forests rich in balsa wood. Historical records document that indigenous peoples from this region built large ocean-going sailing rafts and engaged in maritime trade with Mesoamerica between 600 and 1200 AD. Computer simulations of Pacific currents and winds show that voyages departing from Ecuador and Colombia are the most likely to successfully reach Polynesia. The South Equatorial Current and the trade winds funnel vessels from northern South America directly toward the Marquesas Islands and the Tuamotu Archipelago, right in the heart of where researchers found the Colombian genetic signature. If you depart from Peru, as Heyerdahl did, the Humboldt Current actually flows south along the coast, making departure difficult. Heyerdahl's Kon-Tiki had to be towed 80 miles offshore before catching the currents that would carry him west. And where did he land? The Tuamotu Archipelago, exactly where the genetic evidence now points to prehistoric contact. The genetics and the oceanography align perfectly. Now, here's where Easter Island specifically becomes complicated, and why previous studies reached conflicting conclusions. Easter Island has a unique modern history that confuses the genetic picture. In 1888, Chile annexed Easter Island. Chilean settlers, carrying their own mix of European and Native American DNA, migrated to the island. This created a second, more recent wave of Native American admixture on Rapa Nui. When researchers analyzed modern Easter Islanders, they found two distinct Native American genetic components. One matches indigenous Chileans, particularly the Mapuche people. The other matches the Colombian signature found across eastern Polynesia. The Chilean component is associated with European ancestry in Rapa Nui individuals. It arrived recently, during the colonial period. The Colombian component is different. It's associated only with Polynesian ancestry, not European. It varies little between individuals, indicating it's from a much older admixture event. This is why previous studies were contradictory. A 2014 study found Native American DNA in modern Rapa Nui individuals and concluded there was prehistoric contact. A 2017 study analyzed ancient skeletal remains from Easter Island and found no Native American DNA, concluding the previous study was wrong and all Native American ancestry was recent. Both studies were actually correct about what they measured. The modern population does have Native American DNA. Some of the ancient remains don't. But here's what both studies missed. The prehistoric Native American contact probably didn't happen on Easter Island itself. This is the most important revelation from the new genetic study. The evidence suggests a single prehistoric contact event between Polynesians and Native Americans, but it likely occurred before Easter Island was even settled. The Native American DNA signature is remarkably consistent across widely separated eastern Polynesian islands, the Marquesas, the Tuamotu Archipelago, Mangareva, and Easter Island. All show the same Colombian genetic source. All show admixture dates around 1150 to 1230 AD, and genetic analysis of shared ancestry shows these populations are connected through a common admixture event. The most likely scenario is that contact occurred on one of the islands in the Marquesas or Tuamotu groups during the initial wave of Polynesian settlement of remote eastern Polynesia. This was the era of the Great Polynesian Voyages, when Polynesian navigators were discovering and settling every remaining island group in the Pacific, from Hawaii to New Zealand to Easter Island. The Marquesas Islands lie at the latitude of Ecuador, directly in the path of the currents and winds that would carry vessels from northern South America. Computer simulations show that drift voyages from Ecuador and Colombia most frequently reach the South Marquesas, followed by the Tuamotu Archipelago. Interestingly, Thor Heyerdahl himself, before his famous Kon-Tiki expedition, spent time on Fatu Hiva in the South Marquesas. The islanders there told him legends that their ancestors had come from the east. Heyerdahl speculated that this island might be where Polynesians and South Americans first met. The genetic evidence now suggests he may have been focusing on the right region after all, even if his theories about the direction of settlement were incorrect. Here's what likely happened. Around 1150 AD, give or take a few decades, Polynesian voyagers and Native American voyagers made contact, probably in the Marquesas. Whether Native Americans arrived in Polynesia or Polynesians voyaged to South America and returned with Native American companions remains unclear. What's certain is that admixture occurred. The descendants of this contact then participated in the ongoing Polynesian settlement of remote eastern Polynesia, carrying their dual ancestry to new islands as they were discovered and settled. This would explain why Easter Island, settled perhaps around 1200 AD, shows the same ancient Native American component as islands settled earlier. The people who settled Easter Island already carried this ancestry. Let's step back and consider what this means. Sometime around 1200 AD, people from South America and Polynesia made contact across thousands of miles of open ocean. This wasn't a European voyage with compasses, charts, and supply ships. This was centuries before Columbus. This was prehistoric seafaring that we barely understand. And it completely changes our understanding of human capability and prehistoric connectivity. The Pacific Ocean is the largest feature on Earth's surface. It covers more than 60 million square miles. The distances involved are almost incomprehensible. From Colombia to the Marquesas is over 5,000 miles of open water. Yet somehow, humans crossed this divide. This contact explains the linguistic connections between Polynesian and South American words for sweet potato. It potentially explains other botanical evidence of trans-Pacific exchange. And it demonstrates that our ancestors were capable of maritime feats that challenge our assumptions about prehistoric technology and navigation. Think about what this required. Whether it was South Americans sailing west or Polynesians sailing east and returning, this was intentional navigation across one of the most challenging environments on Earth. These weren't accidental drift voyages. The evidence suggests sustained contact sufficient for genetic and cultural exchange. The Polynesians were master navigators, capable of sailing against prevailing winds using their sophisticated understanding of ocean swells, star paths, and migratory bird patterns. The South Americans built sophisticated balsa wood rafts capable of carrying tons of cargo on trading expeditions along the Pacific coast. When these two maritime traditions met, something extraordinary happened. So why have we been told a simpler story? Why has the narrative of complete Polynesian isolation persisted for so long? Part of it is the nature of scientific evidence. Until we had the genetic tools to detect and date ancient admixture with precision, the evidence was ambiguous. Archaeological evidence like the sweet potato could be explained multiple ways. Linguistic similarities could be coincidental. Small genetic studies produced conflicting results. But part of it is also our tendency to underestimate our ancestors. We want to believe that major transoceanic contact required European ships, European navigation tools, European technology. The idea that prehistoric peoples using traditional technologies could achieve comparable feats challenges our assumptions about human progress and capability. The people of Easter Island and the broader Eastern Polynesian region carry in their DNA the proof of an extraordinary chapter in human history, a chapter of contact, exchange, and voyaging that occurred in one of the most remote regions on Earth, centuries before the modern era of global exploration. This genetic evidence doesn't diminish Polynesian achievement. If anything, it enhances it. The Polynesians settled thousands of islands across the Pacific using traditional navigation techniques that modern sailors struggle to replicate. They built societies on some of the most remote specks of land on Earth, and they had contact with South America during their era of greatest maritime expansion. The story of Easter Island isn't about isolation. It's about connection. It's about human capability, about voyaging, about contact between cultures that we assumed never met. They didn't lie to you about Easter Island because they wanted to deceive. They lied because they didn't know the truth. Now we do. And the truth is far more extraordinary than the myth. The people of Rapa Nui carry in their genetic code the evidence of one of the most remarkable maritime achievements in human prehistory: the prehistoric crossing of the Pacific. Thanks for watching. If you want to dive deeper into the science, I've linked the full nature study in the description. And if you enjoyed this video, consider subscribing because we're just getting started uncovering the hidden genetic history of human populations around the world.